Okay, we're on the section on triangles. Again, once you're finished with section 7, that is, making sure you understand what's presented to you in class, the examples that were presented in class, and that you've done the supplemental assignment, then you should complete out the Math 120 Topic 7 and WebAssign, and then try to enter something productive into the weekly discussion group. So what do we do here? We basically reviewed, some introductory information about, basic triangles, where the uppercase letters A, B, and C represent the angles, such that the sum of the three angles equals 180. And we indicated the sides with lowercase letters A, B, and C. All right. We talked about right triangles. That's pretty simple stuff. Pythagorean theorem applies to the right triangle. And we know the definitions of sines, cosines, and tangent for the general circle. And certainly that applies well since the beginning of the course to right triangles. We have names for those sides. In relationship to the angle, we say it's adjacent to the angle, opposite of the angle, or it's opposite of the right angle, which we call the hypotenuse, right? We derive the law of sines. I want to point out the law of sines can be problematic, particularly if you don't know what you're looking at. It's a good idea to draw a picture, and hopefully any kind of ambiguity will be resolved by drawing a picture. But the law of sines can be deceptive, and we did go through that in class. We also went to the law of cosines. Although it looks difficult, it's a really nice formula to use for solving triangles. Again, a picture would be nice. However, it's not essential with the law of cosines. All right. We derived the formula. Then we went through a bunch of examples. So the examples we went through, we did them in class, did them at the board, little tiny videos there in case you need that. Whatever. All right. There was one ambiguous case. I know that's difficult. That was number 7. Again, a picture will resolve those issues. And then we got to the supplemental stuff. I'll put on what I mean by that. We're over here. What does it mean? Probably should be looking beyond what we're doing in the classroom, looking at your textbook. The textbook is included with your WebAssign. However, you may want to look at other resources, including textbooks from whatever prior schools that you've attended for trigonometry. There's a lot of great books out there on trig. Right? The more you put into this, the more you'll get out of this. Now what we're going to do is I'm just going to review the homework. And again, my hope is that you've done the homework. And by looking at this thing, you're just reinforcing, what you've done by looking at me do it. So I'm going to go through it. I am going to use a calculator for some of this stuff over here, and that's fine. Again, I'll put the exact answers down if I were an exam, but I also want to use a calculator, and I've got a calculator right next to me. One of those dinosaur calculators, a TI 89. All right, so we're in section 7 of the notes. I'm going to switch the screen now. All right, so we're in section 7. And this is the stuff on triangles. And what we're going to do is we're going to do the homework. And again, I hope you're not confused. You're expected to have the homework in front of you now. And again, the hope is that you've done the homework already. Now you're looking at, how would I do it, right? Well, the first thing I would do is, I would read the problem. Now it says solve the right triangle. So the first thing I'm going to do is just simply indicate I've got a right triangle over here. All right, now that's not a triangle. I'm saying I have a right angle somewhere. And it says, the angles A and B are acute and C the hypotenuse. All right. So if C is the hypotenuse, I'm just going to put the letter C down here for the angle, which means 90 degrees. Remember, the side opposite C is hypotenuse. And it says, round the answers, to 2 decimal places when necessary. And so I'm going to put the angle B down. All right. I'm reading this now. And B is 17 degrees. So I can say 17 looks sort of like this over here. All right. So someone says, do you really need to draw an accurate picture of this? Not really, but it sure would be nice to understand that you visually you can understand what you've read. All right. And again, I know that's B over there. What's angle A? Fairly easy to do. What do I know? I know that angle A plus angle B must equal 90 degrees. I think I'm ready to write down what A is. So 17 degrees, I don't need a calculator for this. That's what B is, plus A. Maybe I'll write in the right order. Let me get my eraser out. And so A plus 17 degrees equals 90 degrees. So what does this tell me? A is going to be 73 degrees. Well, that's done. All right, let me keep reading it. And they tell me something about the sides now. And to solve a triangle, I need to know all the sides. All right, so I know the angles. I know all three angles. And I'm going to write down what A is. A is this side, it's opposite angle A. And what's that going to be? 0.98 meters. This is side B. I don't know what it is yet. And this is side C. I don't know what it is yet either. So what I'm going to do over here is solve for those letters now. So let's put this down here. So let's take a look. And I'm going to use the tangent of 17 degrees is equal to, well, that would be the opposite side, right? Which is B, over the adjacent, which is 0.98. I know that's in meters, so my B is going to be in meters. So what's B going to be equal to? Fairly simple. It's going to be equal to the tangent of 17 degrees times 0.98. All right. Now, again, if this was an exam question, this would be a sufficiently good answer right over here. I'm going to approximate it though. And the reason for that is they're asking me to approximate it. And again, if I was on an exam, there's no need to approximate. Just write down the exact answer. By the way, this is in meters. I'll write this over here. All right, let me get my calculator out. And I'm going to, I hope you hear me using the calculator at least. Tan is 17. Times 0.98. We'll look at the answer key later, by the way. And they said rounded to the nearest, like 2 decimal places. So that's going to be, let's see, I have to round it now. So it's a really long number, right? But that's going to be 0.30 meter. And that's me rounding it. All right. Now let's go for C. I'll look at the key later, by the way. How am I going to get C? I'm going to say I'm going to use cosine of 17 degrees is equal to, let's see, adjacent, which is going to be the 0.98 meters, over C. All right. And I want to solve for C now. What's C going to be equal to? 0.98 over the cosine of 17 degrees. Right. This is in meters too. All right. That's what C is. Again, they did ask me to approximate it, so I'm going to use my calculator now. 0.98 divided by the cosine. And what's nice about having a key, I can always look at it to see if I got the right answer. And I'm getting C to be approximately equal to 1, and I want you 2 places though, 0.2 meters. Okay, I'm going to get my red pen out. I'm going to start grading it. I'm looking in the blue area where they say A is 73 degrees. Good, I got that done. All right, let's keep going. Where they say C is 90 degrees. Where they say B is 17 degrees. They're givens, by the way. Where they say A is 0.98 meters. What do they say B is? They say it's approximately 0.30 meters. What do they say C is? Approximately 1.02 meters. All right, number 1 is done. I'm going to go to number 2 now. And number 2 says, an airplane leaves a runway. Its angle of climb is 11 degrees. So I'm going to put the runway down as being a level strip. And the plane leaves at an angle of 11 degrees from that runway. All right. It says the ground speed. I want to point out what ground speed. This is ground is. The plane is doing this, of course, but its ground speed is this. How fast is the ground speed? Well, it says the ground speed is 300. I'll write this over here. The rate is 312 feet per second. All right. It says, how long, this is now a time question, by the way, will it take the plane to climb to 21,000 feet? Yeah, I'm going to draw a right triangle now. Get my eraser out. Eraser's over here. And this is going to be 21,000 feet. The big question is, what do they want to know? They want to know how long it's going to take. So what I'm really interested in is what's the distance here? And I want to put out is something you did in math 1. Distance is rate times time. So distance, the rate's 312. I know this is in feet per second times time, with the understanding that t is in seconds. Okay, so that's what that distance is. So what am I going to do over there? Well, use trigonometry to solve. It's right triangle. So the tangent of 11 degrees is equal to the opposite, which is 21,000 over 312t. I got to solve this for t. Fairly simple to do. 21,000 over 312 times the tan of 11 degrees. For students having trouble with algebra, you should come by during office hours, and we'll certainly be more than happy to help you with that. This is in seconds. This is an exact answer. That was an exam question, and you're doing paper and pencil. Of course, you'd use paper and pencil. There's no need to use a calculator, just paper and pencil. Of course, I want to practice my calculator use. I'm going to pick the calculator up again. I'm going to do this. It's 21,000 divided by 312 divided by the tan of 11. And I'm going to write down what you get. You get t. Whoops, that's an approximate number. I don't want to put an equal sign down. That would be crazy. It's approximately, and they did say use 2 decimal places. Let me write this down. 346.27, and that's seconds. All right, let me get my red pen out and see if it's right. All right, I'm looking at it, and yep, I got it. I feel good about that. Let me keep going. I'm going to go to number 3. And I'll read it to you. It says the angle of elevation from the base to the top of a water slide is 17.3 degrees. So I'm going to say from the base to the top, right? The angle of elevation. These are not very accurate pictures, by the way. 17.3 degrees, right? That's the angle of elevation. I'm looking up at it. So read that again to you. The angle of elevation from the base to the top. Let me put what I mean by this. This is the base, and that's the top of it. Okay? And it says a water slide extends horizontally. Let me put out what I mean by that. It's extending horizontally. Okay? What does it extend horizontally? 43.7 meters. Okay. It says approximate the height of the water slide. Well, this is the height of the water slide. All right. Very simple picture, by the way. So what do I get over here? I'm going to put the tangent down. Tangent of 17.3 degrees is equal to the opposite, which is h, over the adjacent, which is 43.7. Yes, h is going to be in meter. What's h? 43.7 times the tangent of 17.3 degrees. What's the unit on that? It's meters. Again, if this is an exam question, that would be a sufficient answer. Of course, I'm going to use my calculator. 43.7 times the tan. I'm using one of those dinosaur calculators, a TI 80 to 89. We'll talk about Sage later today. And what does this give me? H is 13, and they want me to round it to 2 decimal places, so 6.1 meters. All right, so let's take a look. I'll get my red pen out. And certainly if I make a mistake, I definitely want to correct it. So I'm looking at it and I'm seeing it. I'm seeing the 13.61 meters. Now, what happens with a lot of students that read number 4, they say, oh, it's the same problem twice. Well, it's similar, but it's not the same problem twice. It's really a very similar problem now, but there's a difference in the wording of it. It says when an airplane leaves a runway, climb 11 degrees. We just did this in problem number 2. And again, it's leaving the runway 11 degree inclination there. And keep looking at it. It says the airspeed now is 312. I'm going to put out what airspeed is. This is the airspeed. All right. So what's the distance going to be for that? The distance is going to be 312 t. Now repeat this. It's 312 feet per second. So t is still going to be in seconds. But this again reminds me of problem number 2. All right. So what does it say? When an airplane leaves a runway, its angle of climb is 11 degrees and its airspeed is 312 feet per second. How long will it take for the plane to climb to 21,000 feet? Well, what function am I going to use? The sine function. The sine of 11 degrees is equal to opposite, which is 21,000 over 312t. Again, I need to solve for t. T will be 21,000 divided by 312 times the sine of 11 degrees. All right. What's the unit on that? Seconds. Again, if this is an exam question, you would write that down and walk away. I definitely want to learn how to use a calculator though, and that's why we're asking you to practice this. So let's see if we can do that. So I'm going to write 21,000 on my calculator. I'm going to divide by 312. And I'm going to divide by the sine of 11 degrees. If you can't use your calculator for whatever reason, come by during office hours and we will teach you how to use your calculator, or at least try to help you. All right, what is this going to give me? 352, and we're going to round this to 2 decimal places, by the way. Looks like 75 seconds. Again, I can't say this enough times to you. Look at the answer key to see if you can agree with it. And I'm agreeing with it. And you should feel good when you start to agree with things. All right, let's look at number 5. I'll read it to you. And I'll put it down, number 5. What's number 5 say? And again, when you read these things, you may not understand what you've read, but the hope is over time that you get better with the reading. It says a plane is 76 miles north and 37 miles east of an airport. So I'm going to put my system down, east, west, north, south, something like that. This is going to be north. This will be south. This will be east. This will be west. All right. We're not asking you to memorize what you read, but we're asking you to read it. What does it say? A plane is 76 miles north, 37 miles east. So I'm going to say this is, 76 miles there. And then I'm going to say over here, this is about 37. No, the picture's not terribly accurate, but the plane's over here. All right. Read that again to you. This is where the plane is. This is where the airport is. What does it say? 76 miles north, 37 miles east of the airport, right? The pilot wants to fly directly to the airport. I'm going to say direct means this over here. Wants to fly directly to it. What bearing should he take? I hope you know you're looking at it. He's definitely going in this direction over there to get to the airport. What's the bearing going to be? He must be going south. That's a given, right? He must be going south and he must be going east, all right? Now, some of you might, I'm sorry, I said east, I didn't mean east, southwest, all right? Now, before we write this down, I want to point out to you that, you could say, this in a variety of ways. I'm certainly not I'm not a navigator, but what I want to do is I want to kind of draw a triangle over here. Not a right triangle. And I'm going to write down what the sides of the triangle are. This is 76 miles. This is 37 miles. I point out what I mean by that. 37 miles, 76 miles. What do I want to come up with though? I want to get the angle, theta. Right? We'll worry about what we're going to do with theta once we get it, but let me write this down for you. I'm going to say the tan of theta and again, I'm looking at that right triangle, opposite, which is 37, that's opposite to theta over 76. So theta is going to be the arc tan of 37 over 76. All right. Now, what I want to do is I want to just go through it with you. And what I'm going to say, like if I was talking to a plane, I'd say, and he was in the air, I'd say, you must go south. But you need to turn your wheel, right? This is the theta part, the arctan of 37 over 76. All right, now then you say, oh, in what direction? Well, I got to turn my wheel in the direction of the west. All right, so I'm going to say that's a good answer if this was an exam question, but I want to write down the degree measure for this. And give me 1 second to do that. I'm going to take my calculator and type in arctangent of 37 divided by 76. And that gives me 25. Let me write that down for you. And I'm going to do 2 decimal places. And I'm reading from my calculator, 96 degrees west. So again, if I were speaking to the pilot, I'd say, hey, you need to go south, but 25.96 degrees west. Turn your wheel in that direction. All right. That's one way to write it down. There's another way of writing it down. All right. What I'm going to say, kind of looking at it, and put this over here. I could also say, the first thing I do is I say, I'll go west. Right. But then you got to turn your wheel to the south. And what would that be? 90 degrees minus the arctan. And I'll do this work for you as well. 37 over 76. And that's in the southern direction. Right? This is also an acceptable answer, but I want to write down the degree measure for that. And again, we'll look at the answer key later. Take my calculator and I'm going to do it. This turns out to be 64.04 degrees. All right, I'm going to get my red pen out. I'm going to look at the answers. Okay, and I see the south. 25.96 degrees west. I see that answer. The other answer I see is west, 64.04, and I see south. All right. I also see they put it down in degree minute seconds. You can do that. We've done that in the past. All right, I'm going to go to number 6 now. And I'll write it down for you. Number 6 says use the law of sines to solve the triangle. When necessary, round your answer to 2 decimal places. Well, I'm going to draw a picture of it. I'm kind of looking at it, and I see they've given me one side. And I'm going to write this over here. And I'm going to say this is side B, and that's 84.7 miles. All right. They've also given me angle A, and I'm going to put angle A right here. And they tell me angle A is, like 88.98. It's almost 90 degrees. So I'm going to say this is 88.98 degrees. Now, I want to be honest with you. A lot of students, they say, do I really need to understand how to draw a picture with what you've read? You do. Otherwise, you're really in the darkness about this. And the other thing I want to point out, they've given me angle B. And what's angle B? Angle B is opposite side B. And I'm going to say, what is that? And they say it's, it's 22.3. So I'm going to say maybe, and this would be over here. Pulls down a little tiny bit. They say B, right, is going to be, this is the angle B, by the way, is 22.3. And I don't have a protractor, but I'm going to try to ballpark it. and 90, 45. I'm going to say something like this over here. Now someone says, oh, your picture's really bad now. Not really, right? I'm going to put this over here. I'm going to correct the picture in a second though. And this B is going to be 22.3 degrees. But you know what? I kind of, was overestimating what this was over here. So I'm going to erase it. Right? I'm going to erase this thing over here. All right. And I think I'm ready to go. All right. So what do you mean you're ready to go? I'm ready to finish labeling the diagram. For one, this will be angle C here. This will be side C. This will be side A. They say use law of sines. Well, I'm not there yet, but I'll get there. So I know that A is, I know what B is, and I think I can get C. And why is that? A plus B plus C equals 180 degrees. Well, A is 88.98 degrees, B is 22.3 degrees, and C equals I'm sorry, I don't know what C is, but add them together would be 180 degrees. Now, someone's going to want to use my calculator. I'm not opposed to it, but if you're on an exam, you would be expected to do what I call grade school arithmetic. I'm going to put this down for you. I'm going to erase my grade school arithmetic down in a second now. Add this together. Let's see, 9 and 3 is going to be 12, right? That's 9, 10, 11, 8, 9, 11. Whoa. And then I got to do 180, right? Minus 111.28. So I think I might be able to do it in my head. I'm going to say, let's take a look at that. That'll be 72, right? And what would I get over there? I got to think for a second. I hate thinking, but it's not that bad. I guess it'll be 68, right? Let me see, 68, 69, 70, 68. Yeah, that's right. Okay, so I got C down. 68.72 degrees. Okay. Someone's going, what are you going to do now? Well, I'm going to use the law of sines because they did ask me to do that. And let's write this down. The sine of B, what's B? 22.3 degrees over B, which is 84.7 miles, will be equal to the sine of 88.98 degrees over A. I'm going to take this. I'm going to solve for A. I'll write this down for you. What's A? Sine 88.98 degrees times 84.7 divided by the sine of 22.3 degrees. What's the unit on this? Miles. If this was a paper and pencil exam, this would be the answer you're writing down. What I want to write down, though, is I want to put the decimal number down. And the reason I want to learn how to use calculator. All right, we're trying to teach you that as well. So I'm going to write this over here, sine 88.98 times 84.7 divided by the sine. And one thing is I have an answer key. If I make a mistake, I'll know I made a mistake by looking at the key. At least I hope so, right? And I'm going to put it down, and I'll tell you what I'm seeing over here. I'm seeing A, and I'm going to do 2 decimal places again. It seems like they like 2 decimal places. 223.18. Okay, put a box on it. All right, that's the approximate answer. We'll look at the key later. I want to do another one. And let's say I don't know what C is, right? All right, so let's put this one down. The sine of 22.3 degrees over 84.7 equals the sine of C over side C. I'm going to do the arithmetic on that now. look at the key later. So I'm going to say C is equal to 84.7 times the sine 68.72 degrees over the sine of 22.3 degrees. And what is this? It's in miles. Again, a paper and pencil test. This is what would be written down. I'm going to do the approximate though. And the way I'm going to do that is I need a calculator. That's all I can say. I mean, there's other ways of doing it, but I'm saying the simplest way, at least a modern simple way, would be to use a calculator to do that. $207.99 miles. Again, I know I say it a lot to you, and I think it's important, and I keep saying it over and over again. Mistakes happen. Fess up to them. I'll fess up to it too. Certainly, if I make a mistake, I guess I'll do the problem again. Let's take a look at this thing, and I guess we just did problem number 6, right? So what do they say? Let's see, C is 68.72. I feel good about that. Where they say A is 223.18. I feel good about that. Where they say C is 207.99. I feel good about that. I want to move forward. All right, I'm going to move forward, and I'm going to do problem number 7. Again, my goal here is to get you guys to think about what you've read and to draw a picture of it. So I'm going to kind of put it down, and the first thing I'm going to put down is a side and an angle over here. And what's the angle over here? It's angle B, and that's 133.6 degrees. All right. And then, someone says, where's A and C? Well, they've got to be somewhere. And I'm going to just simply look at the picture, and I'm going to say this is A, and it's 8.7, and these are yards, by the way. And this other guy over here is 2.9 yards. And that's going to be side C. So I'm going to, basically, put the other side in here. Something like this over here. Now someone says, what did they ask for? They asked for the area. I'm looking at it. I want to point out area is 1/2 times the base times the height. All right, I think I know something. I know the base of this triangle is 8.7. Yes, I know it's yard. What I don't know is the height. So what I'm going to do is I'm going to do something that might look a little strange to you. I'm going to draw this on here, and I'm going to be talking about it, what the height is. This is the height. This thing over here. All right. So someone says, how could I figure that out? Well, what I'm going to do is I'm going to be looking at this right triangle over here. What I need to know is I need to know this angle. Well, it's going to be 180 degrees minus 133.6 degrees. All right. Let's take a look at that. So let's see. I'm going to say 134, just, round it up, but I'll get the right number. So 134, let's see, I guess you get what? 46.4. Let me see if that's right. And if someone says, you really do arithmetic strange, and maybe 70. Yeah, that's right. All right. So I'm going to say the sine of 46.4 degrees is going to be the height, right? I know what I mean by that. This is the height over here, and this is the 46.4 height over this thing. What's this thing? It's 2.9. So I think I know what H is. I'll write this down for you. H is 2.9 times the sine of 46.4 degrees. All right, let me write that down. Again, we did 1/2, we did the base, we just did the height. That's going to be times 2.9 times the sine of 46.4 degrees. All right. Now someone says, I wonder what the unit is on that. It's going to be yards squared. Again, if this was an exam question, paper and pencil, that'd be an acceptable answer. Again, I need practice on my calculator. I'm going to go through that. I'm going to take 1/2 times 8.7 times 2.9 times the sine of 46.4. And what does that give you? 9 point, I'm going to use, 3 decimals because that's what they asked for. 9.135 yards squared. All right, this is an approximate answer. What am I going to do? Get my red pen out. I'm going to look at it and see if I did that right. And I'm seeing it. I feel good about that. I'm going to number 8. And number 8 says, to determine the distance between 2 points A and B, this doesn't sound, well, let me put it down. Okay. To determine the distance between 2 points A and B, a surveyor chooses a point C that's 375 yards from A, right? That's not so bad. I guess I could do that. And 530 yards from B. This is a ballpark. I write this over here. This is C. Again, I keep reading it to you. The distance between the 2 points A and B, I don't know what it is, but the surveyor chooses point C, that's 375 yards from A, right? And 530 yards from B. Then it goes on and says the angle BAC, they're talking about this angle, is 49.5. Okay. What does it say? I got to figure out the side C. All right. So, someone says, how would you do that? You might have to keep reading it over and over again, but I got to figure something out over here. And I'm thinking about, well, what can I do? And I guess I don't think the law of sine is going to work out so well. I guess I could fudge around with it for a while, but I'm going to use the law of cosines. So it's going to be C squared equals, this is A, and this is B, is going to be A squared plus B squared minus 2AB cosine of C. Let me see. Do I have? No, I still don't have that, do I? Let me see if I read it right. Determine the distance between points A and B. Search is C. 375 yards from A. 530 yards from B. No, I still don't have C though, do I? You know what? I'm going to use law of sines. Let's go back to it. Let me erase this. I'm not saying it's not going to work out, but I'm going to start looking for angles now. Let's write this down. And it might be a lot of work, but let's take a look at it. Sine 49.5 degrees, that's A, right? Over 530 would equal the sine of B. You get the idea what I'm doing? Over 375. Well, I think I can do this. And we'll write it down for you. 375 times the sine 49.5 degrees over 530 is equal to sine of B. And what's B going to be equal to? B will be arc sine of this thing. I'm just copying, by the way. All right. All right, my distance equation might be, I don't need not tough, but let me keep going. I think I can find out angle C now. Angle C, I know A plus B plus C is 180 degrees, right? All right. By the way, I'm going to put a sort of like a box on this one over here, but not really, because I'm not saying it's an answer. I'm just going to say I don't have to keep rewriting that over and over again until I have to really get an approximate. All right. So what do I know? I know A is 49.5, right? I know B, but I don't know C. Now someone says, why don't you write B down? It's too much work. I'm going to put this down over here. And what's C going to be equal to? 180 degrees minus 49.5 degrees minus the B. A little box in this one too, indicating this is an important fact in the problem. Now what am I going to do? I'm going to figure out side C. So what's it going to be? Sine of C. Yep, you know what C is? Over side C equals, let me remind you, sine of 49.5. Let me remind you, over 530, right? All right, I'm going to try to find C, right? So it's going to be 530 times sine of C over sine 49.5 degrees equals C. This is what goes in the box. Now someone's going to say, I wonder what the unit is on that. Just give me 1 second. You can't remember, go back and read the question. And the question is in terms of yards. So this is going to be yards. Whoops. Okay, I still want to do the calculator. So I'm going to go back and I'm going to get my calculator out. And the first thing I'm going to do is B. So what's B? I'm looking at it. B is arc sine. I'm looking at my calculator. I'm looking at arc sine. And that's going to be 375 times sine. Now that'll work, right? Sine, the calculator's doing work for me though. 49.5 divided by 530. I know what B is. I don't want to write it down, by the way, but if you want to write it down, you can write it down. I'm just going to, write down the computation now, right? So I'm going to say, I'm going to do C now. And that's going to be, let's see, 49.5 plus that number, taken away from 180. And again, I know what that number is now. I know what C is. Right? I know what it is. And I'm just using my calculator. That's all I'm doing. So on my calculator, I want to put how I did. I did this on my calculator, then I did this on my calculator. Now I'm going to do this, and I'll write down the approximate using my calculator. So take the sine of that number. I'm not rounding them off, by the way. I'm just using them as they are. Times 530 divided by the sine of 49.5. And let's see what I got here. Give me 1 second. 530 times sine of C divided by the sine 49.5. All right, and I'll tell you what I'm getting approximately here for this letter C. C on my calculator is 690. Now, by the way, I'm going to read it to you. It's the nearest yard. I have to go beyond that now to the nearest yard. I don't need to put a decimal down. But if I were to put a decimal down, it'd be 0.2959718. That's crazy, right? Yards. I'll circle that. Get my red pen out. Look at the key. And that's what I got over here. Let me point out, paper and pencil test. It's important you identify what's needed in the problem. B was needed. C was needed. And we figured out what the side C was. When I say C, the angle C. All right, let's go to number 9 now. And what does number 9 say? Use the law of cosines, solve the triangle when necessary. Right answer to 2 decimal places. Well, let's write this down. And I guess I got, a side here. I always like to put the flat side down. I got a B. This is tough, right? B's over here. Like I'm not sure what the thing looks like until I draw a picture of it. And then, A is, I'll write this over here, 16.4 meters. And let's see, this on the other side would be, that would be C, right, over here. And they say C is 11.4 meters. That's not so bad. Let me extend this a little bit further. I guess I could extend, maybe a little further, something like that over there. All right, you get the idea. All right, let me finish labeling the diagram. This is going to be angle A. This can be angle C. All right, now what did they say? They said use the law of cosine to solve the triangle. Well, this is B. And let's go through it. I guess I could do B squared, right? So B squared would be equal to A squared plus C squared minus 2AC cosine of 41.8 degrees. I'm sorry, I didn't mean to write that down because I was doing an abstraction. Cosine B. Let's write the letters down now. B squared, A squared is going to be 16.4 squared plus C squared, 11.4 squared minus 2 times 16.4 times 11.4 times the cosine of B, which is 41.8 degrees. I'm going to put B down. It's a square root. 16.4 squared plus 11.4 squared minus 2 times 16.4, 11.4 cosine 41.8 degrees. Put a box in this. What's the unit in that? It's meters. I'll give this paper and pencil exam. That's all you've got to put down. And that's in a box that can be reused if you like. I'll do the computations later. Now, someone says, what are you going to do now? Well, I use the law of cosines, and I want to come up with the angle. And my goal here is looking at it. I want to go for the smallest angle first, right? So I'm going to say, look at the picture. I'll say something like this over here. All right, maybe, it doesn't look that bad. Let's put this down. And I'm going to say sine of C over side C would be equivalent to the sine of B, which is 41.8 degrees, over side B. Now, by the way, B is written down. It's a nightmare. I'm not saying it's not, but it's there. We can do that later. All right, now what do I want to get? I want the angle C. I'm going to push this up. We'll do the computations later. So sine of C, let me put on what we're doing over here. All right, C we don't know, the big C we don't know. Do we know little c? Yes. Maybe I should write that down for you. I'm going to erase that. What's little c? Is 11.4, right? Sine 11.4, sine 41.8 degrees over B. Now, someone says, do you know what B is? I do, but I don't want to write it down. It's right over here. This whole nightmare here. I'm just using the letter B down. It's in a box so I can use it. All right. Now, what's C going to be equal to? Let's move this up a little bit. Oops, not that. I'll move the whole thing up. We'll come back to it later. So C will equal arc sine of this. Again, if this is an exam question, this should be considered an answer. Of course, that's in degrees because we're just dealing with degrees. All right, now comes a big question. What else do we not know? Well, I guess, looking back in the picture, I know B. I still don't know A. So I'll write this down. So what's A? A plus B plus C is 180 degrees. I'll write this down for you. So again, I want to just make sure you understand what I'm talking about up here. I don't know what A is. Do I know what B is? It's 41.8. Again, let me make sure you understand what I said. B is 41.8. C's in a box. A will be equal to 180 degrees minus 41.8 degrees minus C. Okay, what am I going to do now? I'm going to take my calculator. And on the calculator, what I'm going to do is, and again, I'm going to speak through it. Again, for students that are trouble with calculators, and I'm surprised at how many students do have trouble with calculators. They think they can use them until they try to use it, and they realize they're completely befuddled by the computation. And we're not asking you to do the computation by hand, we're asking you to use a calculator. So I'm going to take my calculator out, and I'm going to plug this in. I'm going to do the letter B now, lowercase b. 16.4 squared plus 11.4 squared minus 2 times 16.4 times 11.4 times the cosine of 41.8. And I need to take the square root of that. And I'm going to write this down for you as an approximate answer. As I do that, I want to go back and make sure I'm looking at it, two decimal places. So I'm going to say 2 decimal places, really not that bad. It's easy for me to write down. I'm going to say 10.96, and these are in meters. Okay. One of the big mistakes students make now is they actually start to round numbers off when you should not be rounding them off in the next computation. The next computation, I have B on my calculator. I'm going to use that. I know what it is. I'm going to do the computation for C. All right. And what's C? Arc sine. We'll look at the key later. 11.4 times the sine, 41.8 divided by B. Now I'm not using a 10.96. I'm actually using all the digits my calculator has. And what do we got over here? 43.88 degrees. Again, I'll look at the computation later. Now what are we going to do? Well, I'm going to do the A now. All right, I'm going to put A down, approximate. Yes, I'm using my calculator. And I'm using the C in my calculator. And 94.32. By the way, I realize it's frustrating. I know like a lot of times they get errors and I get errors, so I get frustrated. Got to do it again. Then they do it more than a couple of times, but I got to keep doing it until I get it right. Let's take a look at the answer again, see if we got it right. They say A is 94.32 degrees. I got that right. They say C is 43.88 degrees. I got that right. They said B is 10.96 meters. I got that right. Let's go to number 10. Yep, I know it's tough. What's number 10? Use law of cosine south triangle. When necessary, round answer to 2 decimal places. So let's take a look. And it's got 3 sides, right? What's the longest side? B. Put this down. B is 19.4 miles. And let's see, the next big side would be A was 12.3. This is going to be A is 12.3 miles. Not saying they're terribly accurate pictures, enough for me to get an idea what's happening over here. And then I can put this over here, and this is 7.9 miles, which is letter C. Okay. Now, what do they want me to do? They want me to use the law of cosines. By the way, you don't have to use it more than once. You just have to use it, and you want to solve the triangle. So they want to know what angle C is. They would like to know what angle B is. and they would like to know what angle A is. Now I'm gonna actually go try to find B first with the law of cosines. So let me write this down. So it's going to be B squared is equal to A squared plus C squared minus, right? Let me keep writing this down, 2AC cosine of B. I'm going to keep writing this over here. B squared minus A squared minus C squared equals minus 2AC cosine of B. Now I'm going to keep going. All right. So what do you get over here? Divide both sides by minus 2AC. What are you going to get? C squared plus A squared minus B squared over 2AC would be the cosine of B. Well, I think I know what B is. What's B? B is the arc cosine of C squared plus A squared minus B squared over 2AC. I'll do the computation later, but I'm going to say if this is an exam question, I'm willing to accept it. All right, now why is that? I clearly know all the numbers they're referencing. I certainly know what C is. No, I don't want to square it. I certainly know what A is. No, I don't want to square it. And I certainly know what B is, and I don't want to square it. But all this information here is over there. All right, so I'm going to say I know what B is. We'll do the computation later. And I'm going to say the next thing I want to do is, I'm done using the law of cosines. I'm going to use the law of sines now. All right, how am I going to do that? I'm sorry about that. I'm going to write down. I'm going to say sine of C over C is equal to, well, I know B, don't I? Which should be sine of B over B. I think I can write this down. Sine of C, we'll do the computations later, is C times sine of B over B, where C is arc sine C times sine B over B. Put a box on that. Now, the question is, do I know all the letters on the right side? I know lowercase c, I know lowercase b, and I know B, the big B, because it's written down in a box. What comes next? A plus B plus C equals 180 degrees. And what's the angle I don't know? I don't know A. So what's A going to equal to? 180 degrees minus B minus C. Put that in a box. All right, we're trying to learn how to use a calculator though. So I'm going to go through this with you. And I'm going to clear out my calculator. And I'm going to assign, letters to these things over here. So maybe I should just go through the computation. So let's take a look at that. And I'm going to do, let's do B, the big B. So what's C squared? That's going to be 7.9 squared plus A squared. That's 12.3 squared. And no, I don't need to tell you what that is. My calculator is doing a computation. And then minus the B squared, which is 19.4 squared. Then I'm going to divide that number by 2. I'm going to divide that number by A. I'm going to divide that number by C, which is 7.9. And then I'm going to take the arc cosine of that number. And I'll do that for you. Got to look at my calculator, right? And I get B is approximately 146. And yes, my calculator did the computation, 0.82. I got to be careful looking at that. 0.82, yeah. It's hard to use. When I look at my calculator, it's hard to see the screen. Okay. Now, Bob, that's an approximate. I rounded it off. I'm not going to round it off for the next computation, no. What's the next computation? I'm going to do C now. I want to point out where it's coming from over here. So I'm going to do lowercase c times the sine of that number. And I'm looking at my picture. Lowercase c, 7.9, divided by lowercase b, which is 19.4. And let's see what you get. I'm going to do the arc sine of that now. It's nasty, I realize that. And I'm getting 12. Let me see if I did that right. I got to look at it again. C sine B. Let me see if I did that right. What's C again? 7.9 times the sine of B. What was B? 146, right? Something like that. Again, I'm using the exact values. Divided by lowercase b. And then I'm going to do arc sine. And I'm getting 12. And again, it's really hard for me to read my calculator, but I'm getting 12. Whoops. 12 point. Looks like I'm getting 12.88. All right, let's do A. The last thing we're going to do is A. I'll write it down for you. Again, I'm seeing that over here. I'm using my calculator to do it. Just give me a second to do it. I'm using my calculator again. And again, we're trying to help you get to use your calculators. And that's about 20.30. All right, get my red pen out. Let's hope I didn't get an error. I don't want to do that again. Let's see, what's A? 20.30. What's B? 146.82. And C is 12.88. We did a good job in that one. All right, I know it's a lot of work. Sometimes to discourage, again, the discouragement is a tough time using a calculator. All right, you may have to think about that, especially if you're going to a STEM-related career. Let's go to number 10. And it says, laws, cosines of the triangle. No, I just did 10. I want to do 10 again. And 11. Eraser out. I'll do number 11. All right. A jogger runs at a constant rate 1 mile every 8 minutes. So write this down. The rate of the jogger is 1 mile every 8 minutes. Okay. They're using directions. North, south, east, west. Starting position. Jogger runs at a constant rate of 1 mile every 8 minutes in a direction south 40 degrees east. Okay, south 40 degrees east. You know what? That little chunky looking number there, I'm going to undo it. Okay. Now, the question is, he did it for 20, or she did it for 20 minutes, or he, whatever. So what's distance? Rate times time. So what's going to be 1/8? And we're 20 minutes, right? Wow, that's a nasty number, right? Not really, it's 20/8. And that's going to give you, let's see, that would go on 2 times, right? And then you get 4/8, which is 1/2. So I'm going to say 2.5 miles now. All right, I hope that wasn't difficult for you to do that. All right, and then what happens? When the runner gets over there, they change their course. Right, again, I'm just reading. It says direction now is going to be, let's see, I had to read it. It says the direction now is going to be north 20 degrees east. Oh, whoops. So I'm going to say if that's true, north 20 degrees now east. So this over here is 20 degrees. And they did that for 16 minutes. It's going to be 1/8 times 16, which should be 2 miles now. I'll put this over here. Now, what's their question? They want to know the straight line distance between where they are now and where they started. Okay, I got to figure this out. Well, I'm going to talk about this thing, and what would that be? Well, I guess this reference angle, you'll have a triangle over here, 40 and what would give you 90 would be 50, right? So what would this number over here be? I'll point this out to you. What would that be? That would be, well, that would be 40, wouldn't it? I think I'm ready. I think I'm ready. And I'm going to use the law of cosines to do it. Over here. And I'm seeing it. And I'm seeing d squared now. Yeah, different letters. Is equal to 2.5 squared plus 2 squared minus 2 times 2.5 times 2 times the cosine. What's 40 and 20? 60, right? Let's write this down. D squared. 2.5 squared would be 5 halves, which is 25 quarters. Again, 2.5 is 5 over 2. Square that, 25 quarters, plus 4, minus 10. What's cosine of 60? A half. Yes, you're expected to do arithmetic if you can. I'm going to say, looking at it, it's 25 quarters. And then what do you get over there? 4 minus 5 is minus 1, right? And when you get there, you get 25 quarters minus 4 quarters, 21 quarters. What's the d? Square root of 21 quarters, which is the square root of 21 over 2. What's the unit on this? Miles. I want to approximate it using a computer. I can do that. Square root of 21 divided by 2. And you get 2.29. But they want me to round it off to the nearest tenth of a mile. So 2.29 rounded off would be 2.3 miles. Put this in a box, put this in a box, and let's get the red pen out, see what they got. Now, they got the approximate answer down, expect them to do it. All right, I'm going to call it quits here. And the reason for that is I'm looking at number 12, and number 12 is just a repeat of another problem that we've just done. The only difference now they're using the degree minutes in it, and that's fine. And I'm going to, certainly throughout the class, I did speak about Sage. So 12, I really think it's an easy problem. And Sage, we've done enough of that in class. I hope you're okay with that. All right. Talk to you guys soon.